This lesson is how you trick Matlab into generating a ramp response. We already know that Matlab generates the unit step response, something shown here, but can it do a ramp? Let's try help ramp. And we're out of luck. There is no built-in command. So here's how we're going to trick it. We're going to look over here and notice that the unit step in time is 1, and in Laplace is 1 over s. The ramp input in time is just t, and the Laplace is 1 over s squared. So all these guys differ between the unit step and the ramp is there's an extra s 1 over s squared. So we'll use that fact to trick Matlab. Here's how we'll do it. The typical step function in Matlab, it knows 1 over s is the input. You supply the closed loop transfer function. It generates the output, and then Matlab does the inverse Laplace transform on that guy to produce the unit step response in time. We'd like to have a ramp function that was 1 over s squared, and we would input our closed loop transfer function, get the output, and generate the corresponding ramp time history, but we don't have that. So what we're going to do is give one of these s's to a new augmented closed loop transfer function, and that's going to be our input to the step command that's going to give us the ramp output. So we'll take one of these s's, append it or augment it to the closed loop transfer function, use that as the input, and get our step response. So let's do that. First we need a closed loop transfer function. We use the one we had before, as good as any. So I need to build now this augmented closed loop transfer function. So let's call it aug CLTF equals series. I need to series a 1 over s to that guy, so I'll put in the TF command inside this series command. 1 is the numerator, the denominator is 1 and 0. That corresponds to a 1 over s transfer function. And we're going to augment that guy or series that guy to the original closed loop transfer function. See what that does. Alright, upon inspection it's the same function as that with an extra 1 over s in the denominator. Alright, so I've built that. Before I plot the ramp response, let's go ahead and look at what the closed loop step response was for our original closed loop transfer function. So we'll type step closed loop transfer function and refresh ourselves. Yep, that's what the step response looks like, and we're good to go. Now let's type in step of the augmented closed loop transfer function, see what that looks like. Alright, that looks like a ramp response. Let's zoom in a little bit on the axes here. Alright, we're zoomed in a little bit. Maybe we should put the input alongside here so we can see how this guy's tracking a ramp input. So I'll go ahead and say hold on for the plot, then I'll plot what the ramp input would be. 0, 100, 0, 100, and I'll go ahead and make that green in color. Alright, so come over here. So that's what the input is. The green input is a ramp, right? A time function, t. So it has a slope of 1. And then this blue line is our ramp response of our system to this input. So clearly our system, even with feedback and all that stuff, does not track a ramp input well at all. There's tons of error, and the error grows with time. But nonetheless, we were able to generate the ramp response using the step function by cheating and making this augmented closed loop transfer function where we added 1 over s times the original.